In the UK, we plant something like 45 million trees per year, and most of those are planted using tree shelters to protect them. Some 2,500 tonnes of these tree shelters end up in the natural environment at the end of their lives.
I've been involved with tree shelters since their inception, which was early 1980s. I think it's fair to say that there are millions of trees alive today and thriving as a result of tree shelters. People have tried different materials, but they're either too heavy, too fiddly to install, they won't last the duration. What we have to be sure about is that the new tree shelter will do exactly what the old one does, only by using a bio-based plastic that's going to have no impact on the environment.
We've been working with a number of the UK's leading universities over the last 6 years and have invested some £6.5 million on a whole new generation of biopolymers. A number of these new polymers are derived from lignin, one of the materials that comes from trees.
It is the first time we're using these biodegradable polymers from this research, so it is really exciting. So we're basically using wood to protect trees to make more wood, which is fantastic. Biome is used to make biodegradable polymers since 14 years already, so biodegradation won't be an issue for us. The challenge is to control the timing. We're adding into the formulation some natural antimicrobial. Over time, the antimicrobial will lose its power, and then the biodegradation will start.
In the environment, the tree shelters, they're going to be exposed to rain, hail, heavy wind, and also some small attacks by different animals. So for this, they need to be stiff enough to resist those attacks, but also flexible, so they don't break. To see how the material is going to respond, we perform different tests in the lab. We test the MFI, the melt flow index, that's important for processability. Impact resistance, that gives a good indication of the toughness of the material. Then we perform a flexural test, which gives an indication on the stiffness. Something that can happen due to UV irradiations is the breaking down of the polymer chains. We need to add the right amount of UV stabilizers in order to maintain the mechanical properties just for the time we want.
Accelerated weather aging permits us to assess how our material would behave over the time. Over a period of 40 days, the material will be exposed to the same amount of UV, rain, and heat than it would normally face in a 2 years period in real outdoor conditions.
Having tested these materials extensively in laboratory conditions, it's now time to test them in the real world. The next step is to work with Shaw Green to manufacture some 20,000 tree shelters, which we'll plant at various sites around the UK. The UK government has pledged to double the amount of tree planting over the next few years. To support this, we need tree shelters that break down naturally at the end of their working lives and return harmlessly to the soil.
UK still has the lowest tree cover in Europe, just 13%, and yet everybody knows that the benefits of trees are enormous. I would love my legacy to the country, if you like, the world of tree shelters, to be a biodegradable one.